Good morning. My name is Jane Tricker and I'm supporting the Holmes England Local Government Capacity Centre. I'm delighted to welcome you to our Winter Learning Session programme. This offers a series of knowledge sessions on topics that you have asked us about. These are topics that are very relevant in today's world. So today's event, and this one is such a topic, today's event is about future-proofed energy solutions. Next slide, please. So the Winter Learning Programme is brought to you by Holmes England's Local Government Capacity Centre. This slide summarises who we are, what we do, why the centre was launched, following extensive consultation with local government and other organisations, so that we determine where authorities need most support and how best this can be delivered. And we'd like to hear more views about that today at the end of the session. Okay, so on screen you will now see the breakdown of the session today. Shortly I will hand over to Emir, and Emir will be leading on a session about Holmes England's approach to future-proofed energy solutions. And then Richard and Stephen from OVARUP will share their methodology used to explore initial energy options for a number of sites across Lincolnshire. And they were 4 quite different sites. So from those 4 sites, Richard and Steve have also drawn together some really powerful insights. So that would be good to hear about. And then Kate Bell from the City of Lincoln Council will share some quite leading edge planning policy work that herself and colleagues have been doing. Talk a little more about energy options and engagement with the public sector. Emir will then sum up for all the speakers, going through some key takeaways for you, topics and further areas of learning where the presenters think they might be of interest for yourselves. And then finally, at the end of the session, we'll just have a few minutes on final thoughts. And then please don't leave then, because after that, we're going to run our polls asking you what you thought of the session and what other sessions you'd like to take part in future. And even if you'd like to do a bit of a deeper dive on future-proof energy solutions. At the end, in addition to the 3 polls for your feedback, in the chat there will be a questionnaire which you can take away with you and at your leisure think about all the things that you would like to hear more about, and think about how the session went and tell us your thoughts. So thank you very much for that. And I think it's for me now to hand over to Emir, our lead on energy within Holmes England.
Thank you very much, Jane. So, yes, my name's Emir Poole. We'll welcome you all to the session. I'm a technical manager within sustainability within Holmes England, and my background is in sort of architecture, planning, town planning and engineering related to sustainability and energy in particular. Next slides, please. So why are we talking about this today? Future-proof energy solutions. We hope that even though we've got a big download of information to give you today, that you'll take away a little bit more about the government policies around environmental issues, the emerging future home standards in particular, which is an area I'm going to cover, the environmental bill, and what Holmes England does to support this agenda, and how we can support you, our sort of partners, in our kind of joint aims in this sphere. So next slide, please. So we're going to run a poll now. So we want to hear from you again, which is basically, kind of which best describes your area of work. So we're trying to get a feel for the audience here, really. So just please click on the poll as you did previously to participate. I think while you're doing that, I'll kind of move on to the next slide because we've got quite a lot of material to get through. Thank you very much. So basically, in terms of our kind of overall mission, although this is ever changing as we respond to the market, so we're working on corporate planning and future planning, obviously, as behind the scenes. But our mission, as it stands, is to intervene in the market, ensure more homes are built, and improve affordability. And we have a kind of it's embedded within our Act. Sustainability is embedded within our Act. So we want to create a sustainable and diverse housing market. Next slide, please. In terms of our current direction, the UK as a whole has a legally binding target of net zero for 2050, and it's recognised that the housing sector will need to play a critical role in this. There's a lot of emerging government policies around this. In particular, I think the ones that will focus on the future home standards and the Environment Bill, which is a sort of wider piece of legislation. And we look to support this agenda, and where viability can be maintained, we will support our partners' ambitious aims in this area. Next slide, please. So I'm going to talk a little bit about the Future Home Standard, which kind of sits, it's not standalone. So the reason I put a few of the other documents up here is that it sits within a suite of other complementary pieces of policy, like the design codes, biodiversity, and various other energy policies, which are national, not necessarily related to housing, but are interrelated. So I think the key issue here is that what I'm going to talk about today, there's a much wider pieces of work going on, and it sits within part of that. Next slide, please. So in terms of things like the 10-point plan, I mean, the aim here is for the government to reduce its carbon dependency effectively. So there's a series of tonnage of carbon which needs to be reduced between 2023 and 2032. There's a big focus on decarbonising the grid, and I think my colleagues from Arup are going to talk about that a little bit later on. But there's a big push towards offshore wind, new nuclear, and so on. But the fundamental point here for us is that there's an increasing electrification of the grid. So there's implications for us in terms of things like our car charging for electric cars, electrical heating, etc. And the government has ambitions to do some low carbon hydrogen at scale as well, village and town heating. The fundamental issue for us with building homes is that we're looking to create greener buildings. So it's a move away from fossil fuels, gas boilers, towards electric only solutions. And I'll talk a little bit about that in the future home slides coming up. So next slide, please. So the key points. Responding to the consultation, the government has decided that all new homes will have low carbon heating or will be zero carbon ready by 2025. So no further retrofit work needed to enable them to become zero carbon, and the grid will decarbonise to make up the rest. So new homes will be expected at the point of sale, if you like, to produce 75 to 80% lower carbon emissions compared to current bills. So it's actually quite a significant step change in regulation. And there's an additional requirement for new homes to have a reduced carbon footprint of 31% by 2021 compared to the current levels. So it's a shift in terms of the supply chains we utilise currently, away from things like gas boilers towards renewables, heat pumps, and so on. So next slide, please. So some of the possible implications, I've just mentioned those, but things like heat pumps, heat networks, and perhaps electrical heating may be the principal means of producing low carbon heat when gas boilers become obsolete. The government, we work with BEIS quite a lot, sees heat networks as an important part of its low carbon heat plans, and particularly in cities in high density and regeneration areas. And the industry is getting to grips with what this might mean, including some sort of roadmap to achieve compliance, and sort of work out what the cumulative impact of this and other legislation and regulation is, and what technical issues might emerge. And I'll talk a bit about that in a moment, and the likely costs. Next slide, please. I and others have had some previous interventions within heat networks and in Holmes England. This is an example. This link here, this will be in your resource pack, but it's an example of some best practice that was produced with the predecessor to BEIS. We continue to work with BEIS on capital programs around integration of heat networks in residential areas. Next slide, please. We've done some industry intelligence, if you like. So we've worked a little bit with Vimal Bana from Dual Infrastructure, who works very closely with all the leading sort of private house builders. and he's done a little bit of work for us on some of the issues around, you know, what the implications for developers. There's not a huge amount for the interim arrangement. Most developers think, you know, they just enhance fabric improvement, and some of the on-plot measurements, such as photovoltaic cells, solar panels, basically, and heat recovery within the buildings, are fairly well understood. So it's just sort of slightly additional cost and a slightly modification of the design teams of what they're already producing. A lot of them are considering communal solutions and heat pumps, and, you know, there's some turnkey solutions turning up to sort of address some of those issues. The 2023 transition, it does include the Fabric Energy Efficiency Standard. Now we've had confirmation of that. The developers think this results in cavity wall increases. So, you know, that's issue. There's issues there about land take. I've put there in brackets. This is now confirmed, and for us, that obviously impacts on things like, it could impact on receipts and profits and so on site and viability. So it's something we need to understand better. But the likely benefits of this initially is that we can test some of these issues on site. So the Future Home Standard, then, you know, what we're seeing coming through is primarily on-plot solutions, not district. So individual air source heat pumps with renewables. Things like electrical and hydrogen boilers are still in their infancy. Major developers seem to be storing up air source heat pump supply chains, and a similar trajectory, we think, to PV, where you get a price spike and then the economies of scale brings the price down over time. And we're getting current quoted costs, you know, for a plot of anything from £10,000 to £20,000, and this is varying massively depending on people's supply chains and obviously other wider economic situations. There's other considerations on site, such as, you know, the demand to charge, so substations and things like that, and battery storage. And there's no real standard product, as we can see, emerging yet. Next slide, please. We've put here, this will be in your pack, so this is more for reference for you to take away, really. But it's just in terms of what we're seeing in terms of the individual communal sort of solutions and the additional costs. I think these are just, you know, we've just done some early estimates here, and we're doing a bit more research to find out how actual this is. As I say, these costs will probably drop down over time as economies of scale kick in. The next slide, please. In terms of some of the additional consideration, there's obviously things like for district heating, things like heat regulation is a big issue for the industry. There's a heat trust currently, but the industry is, you know, keen to sort of move towards much more regulation with assurances and an ombudsman and so on. Electric vehicle charging, which impacts on it. Transport policy, another part of government, requires us transition to EV. And that's obviously creating demand side on some of our sites in terms of substations, and opportunities potentially for diversifying peak spread, so using the car batteries, you know, to manage loads and so on. Changes to the Part L, which is the building regulations. These are just, you know, kind of there's various pilot projects we're working on, which I'll talk about in a little bit more detail later on, which is, you know, which we're trying to help inform the industry and yourselves about what these costs and likely issues are. So Holmes England are looking to advance electrical or heat infrastructure as part of normal enabling works, and especially on sites crossing the 2025 threshold. And as already talked a little bit about the pilot scheme, so no gas to sites. Okay, next slide, please. The Future Homes Task Force have produced this slide, and we work very closely with the Future Homes Hub, which is basically represents the house builders and industry. And, you know, they've obviously highlighted that it is even just on a standalone building, there's dozens of changes that are needed for your typical net zero house. And we've talked about some of these already, which are fabric improvements, heat improvement, you know, low carbon heat infrastructure, energy infrastructure, new tech, some demand leveling, renewables, electric vehicles, etc. So lots of changes from a standard house build. Next slide, please. As I mentioned, Holmes England are doing some pilot projects, and we've got a range here that show you geographical spread. We're also looking with other partners at bringing more into this piece of research, but we've had some funding to do some actual builds. So we're going to build some units on each site, you know, to the nominal Future Home Standard, and we're going to have an open book appraisal type approach to that. So we'll present that research out to industry and yourselves, so we can see what the costs are, different approaches, what works, what doesn't work, and, you know, hopefully create a sort of virtuous circle of research so the industry gets more intelligent really about how we do this in practice. Next slide, please. And with this, we're bringing obviously a kind of series of different stakeholders together, some industry bodies, some consultants, some of the UK's leading house builders, as well as government departments. So, we're feeding back into regulation as well. And that sort of stakeholder engagement is essential. And particularly some of our other partners are also doing similar things. So we're kind of trying to not reinvent the wheel on site-based stuff, but actually kind of informing each other's pieces of work. Next slide, please. So this sort of closing slide really sort of brings me back to my earlier kind of note, really, which is Future Home Standards sits within a wider series of policies for us. So we've got a design quality and placemaking role, we've got a biodiversity role, and we've obviously got the climate change role. So this is just a reminder, really, that what I've just talked about sits within a wider suite of policies and documents at site level. Next slide, please. Thanks. And then ultimately, what we're trying to create at the end of the day is sort of good quality, sustainable, functioning places. Kind of the technology is one side, but it's but ultimately we need these places to work. So next slide, please. So if, we're going to move on to Rich and Stephen at Arup now. I'll give you a bit more detail on the applied policy from a consultancy perspective. Thank you very much.
Thanks, Amir. My name's Richard Knights. I'm an Associate Director at Arup, and I'm going to present this next session with Steve Caraher, my colleague. Holmes England employed Arup to look at some new development sites in the Lincolnshire area last year, with a focus on how these developments could be net zero in terms of energy use. We're going to talk about what we did, the outcomes, and the key insights. But before we do that, we've got another two polls. Next slide, please. So the first poll is a multiple choice. You can select up to two. The question is, what is the key enabler for achieving net zero carbon in new housing in the UK? So you can choose up to two of these. And I can see that a lot of results coming in for policy, outstripping everything else. Some for perception of changes, but definitely policy is being seen as the biggest key enabler at the moment. Could we have the next slide, please? The next poll is very much a follow-on about these 5 key enablers, and it's asking the question, how many of these key enablers can you influence? So that is, I think, you personally, and you've got the choice of none or 1 or 2 or 3 or 4 or 5. So how many can you influence? How many of you can influence policy, since policy seems to be the key enabler? That'd be quite interesting. And well, many of you are saying that there is 1 or 2 that you can influence. Well, that's actually probably quite a hearty response. I'm going to pass over to my colleague Steve Caraher. I'm going to return towards the end to talk about some of the key insights. So over to you, Steve.
Brilliant. Thanks, Richard. Could we just jump onto the next slide, please? Great stuff. So, as Richard mentioned, we delivered the Lincolnshire Sites Energy Options project, and as a short introduction to this project, we essentially provided high-level energy strategy support to Holmes England for 4 new development sites across Lincolnshire. These 4 development sites were broadly classified into 3 site typologies, and you can see these on the right-hand side. So the first one is the large mixed-use urban development. So this was development that consisted of new housing and other building types, such as offices and academic buildings, all located in existing urban areas. We looked at urban housing extension. So that was development consisting of new housing extending from existing development sites located in existing urban areas, and also rural housing extension. So that was development of new housing extending from existing housing developments located in rural areas. So one of the key focuses of our study was on how energy systems can help to achieve operational net zero carbon for these new development sites, but also critically linked to that was consideration of the resilience and the commerciality of these energy options as well. So we just go to the next slide, please. So in terms of the methodology that we used for this study, we started with a policy review, and that helped us to identify the direction of travel for buildings and energy systems in the UK. And this helped us to ensure that our approach was well informed and future-proofed. We carried out an energy demand analysis to determine the peak and annual heating, cooling and electricity demands for buildings across each development site. We used a multi-criteria analysis matrix to assess what was essentially a long list of energy supply options in terms of their suitability for the development sites. So that was considering a range of technical, commercial, environmental and strategic factors. And the results of the multi-criteria analysis, which were essentially the highest scoring technologies and those that we found most suitable, were then used to develop what we called energy supply scenarios. And these consisted of combinations of the most suitable technologies with the highest score from the analysis that would supply heating, cooling and electricity to buildings across each site. And then for each of these supply scenarios, we then carried out additional assessment in terms of advantages and disadvantages, also considering commercial implications, but critically as well, we carried out an assessment to calculate the theoretical operational carbon emissions for each of the scenarios up to the year 2050. Next slide, please. So here we have some of the outcomes for the large mixed-use development and urban extension typology. I mentioned previously that we used the results of the multi-criteria analysis to determine a number of supply scenarios. Broadly, the results of the analysis showed us that the most suitable technologies for the development were likely to be solar PV, particularly roof-mounted, air source heat pumps for heat supply, and ambient loop network to supply heating in domestic buildings and non-domestic buildings, and cooling in non-domestic buildings as well. We then took these forward for further assessment in terms of advantages, disadvantages and carbon, which I'll talk about a bit later on. But in terms of an overview of the supply scenarios that we arrived at and assessed, we started with a business as usual scenario, and this really acted as almost a historic reference point representing the sort of current common approach, which is in existing buildings, which is gas boilers, grid electricity supply, and also electric chillers for cooling in non-domestic buildings. And this acted as a useful baseline against which we could compare the low carbon scenarios and technologies. Scenario 2 consisted of what we would call decentralized generation options, or building integrated generation options. So we looked at and modelled building integrated air source heat pump, rooftop solar PV and solar thermal where appropriate, and also electric chillers for cooling in non-domestic buildings only. For scenario 3, this consisted more so of centralised generation options with heating and cooling provided by an ambient loop network, with electricity supplied by grid connection and rooftop solar PV. So for those of you unfamiliar with ambient loop networks, they're essentially a form of heat network that operates at much lower temperature, and is a network of underground pipes that provides energy to buildings. But crucially, these networks can use renewable heat sources such as the air, the water, and the ground, and can also use recovered waste heat as well. So it can be quite efficient and low carbon solutions. And for context, the ambient loop that we modelled for these sites particularly was supplied by boreholes, which were recovering heat from the ground. Next slide, please. So in terms of some of the key takeaways for the large mixed-use development and urban housing extension typologies, we found that there were greater capital costs associated with installing the low carbon infrastructure and technologies in scenarios 2 and 3 compared to the sort of business as usual gas boiler approach. However, critically, this was balanced against significantly lower carbon emissions for both scenarios compared to the reference case scenario 1. I'll touch upon some of the more quantitative elements of that a bit later on. We found that the ambient loop network in scenario 3 presented opportunity for generating a return on investment for the network developer, or the building developer even, and the network operator through the sale of energy to customers via the network. So there was opportunity for a business case for investment in this low carbon infrastructure. However, there was also a large land area associated with the ground heat recovery system to supply this network, which is a key consideration for developments. We found that consumers were less likely to be familiar with heat pumps and solar panels than the usual sort of gas boiler and grid connection approach. And there's also a more challenging construction associated with these sorts of low carbon infrastructure compared to the business as usual, particularly for the ambient loop network, which would require cross-party collaboration at scale. We found that based on 2021 prices, there would be a small increase in energy costs for consumers. However, this may change as the UK government tries to address energy prices in the UK, which are, of course, quite a challenge at the moment, and also uncouple the price of electricity increasingly from the price of gas. So the key takeaway there is essentially that there are some challenges and cost increases associated with these scenarios 2 and 3, but of course they have significantly lower carbon emissions than the current gas boiler approach. Next slide, please. So as I mentioned, we also looked at a development site that was classed under a rural housing extension typology. So this results were broadly the same, however, there's a couple of niche differences. So scenarios 1 and 2 were modelled as the same. So that was the gas boiler approach and reference case in scenario 1, distributed generation with air source heat pump and solar panels in scenario 2. The key difference was that we found that rural housing extensions typically don't have sufficient economies of scale to support a centralised ambient loop network. So in line with that, we considered and modelled building integrated ground source heat pumps with roof-mounted solar PV and solar thermal where appropriate. Next slide, please. So as the scenarios considered there were broadly similar, for scenarios 1 and 2, the results we found for this typology were very similar to the large mixed-use development and urban housing extension. However, I've circled a couple of key differences associated with scenario 3, and this is broadly due to the difference being the presence of the building integrated ground source heat pump compared to the ambient loop. So quick summary of these: the building integrated ground source heat pump presents limited opportunity for that return on investment for developers compared to the ambient loop, which offers more of an opportunity for a business case there in return on investment. And although the implementation of ground source heat pumps would be challenging in practice, particularly at scale and in many buildings, and associated with the ground heat recovery infrastructure, we found that on the whole it would be slightly less challenging than an ambient loop approach, which would require cross-party collaboration at scale. Next slide, please. So we gained a lot of qualitative insights from our analysis as well as quantitative, and to give you an overview of a couple of these here. We looked at large mixed-use developments and urban housing extensions, which would typically have, we found would typically have sufficient economies of scale to support ambient loop networks. And as previously mentioned, we found that rural housing extensions would not necessarily. We found that waste heat from cooling processes in non-domestic buildings like offices could be recovered into the ambient loop network, and this would improve operating efficiencies. We found that low carbon infrastructure in urban housing extensions could be extended to benefit nearby and existing developments, and this enhances the value proposition potentially for investing in low carbon infrastructure. We found that because the low carbon technologies across each of the typologies were powered by electricity, we'd be anticipating an increase in electricity demand on the local electricity network, particularly for large developments. And this is a key consideration as the grid becomes increasingly constrained in terms of capacity. We also found that electricity regulations limit the amount of electricity that can be supplied to homes via a private electricity network to 1 megawatt. However, this limit increases to 50 megawatts for renewable energy supply to businesses. So what this really translates to is, if there's an aspiration to generate renewable energy alongside the development from a solar PV array, for instance, on site or off site, and then supply this to customers on site via a private network, it's much easier from a regulatory and potentially commercial perspective to supply this energy to businesses rather than homes. Next slide, please. So in terms of some of the quantitative insights that we gained, there's an example of some of these here, and it's worth noting that these figures are highly indicative and dependent on a range of factors, so they'll differ quite a lot from development to development. But along the top, you can see some of the results for the large mixed-use urban development typology, and along the bottom, we've got some results for the rural housing extension. So as part of our assessment, we calculated the amount of additional solar PV that would be required beyond what would be installed on rooftops on buildings to supply the development with 100% renewable electricity, and thereby essentially achieve an operationally net zero carbon energy supply. And as you can see, there was significantly more solar PV required to achieve this for scenario 1, with the gas boilers, the business as usual, compared to the lower carbon scenarios 2 and 3. And in line with this, the area that would be required for the solar PV was much greater for scenario 1 as a proportion of the GFA for the development, and obviously much lower for scenarios 2 and 3. So this is a critical sort of consideration in terms of the balance of achieving net zero carbon and the land requirements associated with that. In practice, we recognise that operational net zero carbon might not be achieved by only developing additional renewables on or off-site, but this sort of metric gives us a useful reference to help us understand the scenarios and the implications for net zero. In the centre, we've got a ratio of grid connection requirements for the scenarios. So as you can see, the grid connection requirements for scenarios 2 and 3 were much higher than for scenario 1. And this was again due to the fact that the technologies, energy supply technologies in the scenarios were powered by electricity. Scenario 3, we found to have lower grid connection requirements, and this was mainly due to the fact that the generating technologies in these scenarios, so they were namely the ambient loop network and the ground source heat pump, were found to have higher efficiencies than the technologies for scenario 2, broadly the air source heat pump. And towards the right hand side, we found that for sites that had suitable ground and hydrogeological conditions for open loop boreholes, that around 10 open loop boreholes were required per megawatt of heat demand to supply the ambient loop network. And then towards the bottom, this really, on the right hand side, this really reiterates the point that we found that on an annual basis, the carbon emissions associated with scenarios 2 and 3 were significantly lower than for the sort of, scenario 1 business as usual reference case. So that hopefully provides you with an overview of some of the insights and outcomes from our study. I'll pass back over to Richard now to discuss some of the shared learning and further insights.
Next slide, please. Thanks, Steve. So looking across all the 3 development types, there were some areas that we can sort of key insights that we've drawn. Firstly, with regard to renewables on land, to get to net zero, you cannot put enough renewable technology on buildings. You have to have additional renewables, and this requires additional land, either on the site or off the site. And either can be done, and how far away from the site the additional renewables are, it becomes effectively a commercial matter. As Steve has indicated, where there are businesses on site, there can be some distinct commercial advantages with connecting renewables directly to the businesses, both for the developer and for the businesses themselves. There are also additional costs for the construction of the buildings. Amir has sort of run through those as well. It's a very similar list: building fabric, heating systems, heat pumps, hydrogen boilers, heat networks. They all cost much more to construct than the the common gas boiler that we've been used to, solar on roofs, solar thermal, where heat is generated from equipment on the roofs. So they all add to building construction costs. And to get to net zero, buildings will be more expensive. There are also additional costs in the infrastructure. Steve has mentioned how the electricity grid connection needs to be bigger. That will be more expensive. There's also supply of heat needed. That's either even a greater electricity connection, or it's a heat network, or it's perhaps producing hydrogen, and all these are far more expensive than putting pipes in the ground to supply natural gas. So there's an infrastructure additional cost. And similarly with renewables to help bring the site to net zero. Some of these things may have government support, but for the larger infrastructure like near site renewables and like heat networks, there is an opportunity for third-party investors who invest in energy systems to take that capital cost and make a business out of it over the long term. Steve mentioned that we found that there was energy cost increases for consumers. So we did this work early in 2022, and we're essentially using reference energy prices from mid-2021. They're clearly a lot higher today. But even at those mid-2021 levels, all the consumers had higher energy costs. Whilst these inflated energy prices may drop a bit in the short term, and electricity prices may drop even more in the longer term, in the short term there is likely to be an issue that consumers are paying more for energy to get net zero on new developments. And then economies of scale, as again mentioned by Amir, there are economies of scale, particularly using centralized systems like heat networks and renewable energy on larger scale projects. Next slide, please. Development, and particularly housing development, has a part to play in solving this big net zero challenge, this challenge of minimizing climate change. And it would be really nice if we could just carry on as normal and let the electricity grid get us to net zero. And this is the forecast from BEIS of where electricity the carbon content of electricity going forward. It gets nearly to net zero, but as I'm sure most people are aware, it's not where we get to, but it's how quickly, or at the moment how slowly we get to there. It's the area under the graph is the CO2 emissions. So we can't just wait for grid decarbonisation to solve the problem. We have to put in renewables to get the carbon emissions down quickly to minimise climate change. Next slide, please. So this is the concluding slide on this section. There are so many different variables, so many different elements that affect how you reduce the carbon of energy on new developments, how you get to net zero. And what really is needed is to think about them all together. So we've done this diagram sort of showing how these things link together. We've shown things like building fabric, heating system, off-site renewables, affects house prices, affects land value, government and regulation, including planning. These things are all linked together. There are other things we could have added, like vehicle charging. And these things compete against each other to some extent, and they need to be looked in relationship to one another because they are so interlinked. A whole system approach is needed to try and get new developments to low carbon. Next slide. Just to finish this section, we have 3 more polls. The first one, perhaps a rather challenging one. So if you had to include renewables in your development, so that's beyond what you can put on the buildings, would you rather buy extra land or reduce the size of the development? tricky question, but one I think that is potentially a real question in the short term. So that's the poll. Can't see anything coming up at the moment on that. Perhaps I can now. Yes, I can see something. And it's a slight more to reduce the size of the development than buy extra land. That's 60-40 in favour of reducing the size of the development. Next slide, please. And so some questions now about how public perception. The first one is how much extra are people willing to pay for a zero carbon home? And we've given you ranges from -20% to +10% in 10% blocks. How much are people willing to pay for zero carbon homes? And again, I just wait while that comes up. Yes, it's coming up. And 0% started off scoring very highly. And it seems focusing around 0 to 10% is what is being put on there. That's your feelings. And the next slide, please. A similar question: how much extra are people prepared to pay for a low carbon home? And we're given again slightly bigger range, -20 to +20, with -5 and +5 added in. And it's showing sort of between 0 and 10 plus 10% is where you think that one is going. I'm going to hand over to Kate Bell now. So the next section, Kate, over to you.
Thank you, Richard. So my name's Kate Bell. I'm the Climate Change Manager for the City of Lincoln Council. I'm going to talk a little bit about the value of energy options studies that ARAP have completed within Lincoln from a local authority perspective, and then some of the policy drivers that we have in place to really push this forward in terms of reaching our net zero ambitions. Next slide, please. So, like with many local authorities, Lincoln declared a climate emergency back in 2019. And then we had a really clear and strong message from our leadership that this was had to be about climate actions and not just words. So prior to that declaration, we completed a science-based targeted review of where we are in terms of our net zero before we then set an ambitious target for Lincoln to be net zero by 2030. And that's a citywide target. So it was essential that we do this as a partnership approach. It doesn't just lie within the powers of a local authority. So we already had a partnership, but we looked at how we could strengthen and expand that partnership, give it a bit more oomph. And we formed the Lincoln Climate Commission, which was established back in 2020. And we've been working with that partnership to prepare our Lincoln 2030 Climate Action Plan, which we published last year. Next slide, please. So alongside the work of the Lincoln 2030 document and the partnership work, there was also an opportunity to review the Central Lincolnshire Local Plan. Now, Lincoln has a joint local plan with our two neighbouring local authorities, both of which, or all three of us, have declared a climate emergency and have set very ambitious net zero targets. So we had a very strong steer from leadership across the three local authorities that we had to reflect that challenge and that ambition within the Central Link's local plan as much as we can within the powers of a local plan. So we did a really detailed piece of work around reviewing policies, establishing really solid evidence base to support those policies so that they would be viable. And I've listed a few of those, but there were a whole load of new climate policies, but I've listed the energy policies in this slide, looking at the principles of efficient buildings, reducing energy consumption both in residential and non-residential, creating a clear route and a policy support for decentralized energy networks, and then the embodied carbon. So not just looking at what happens after the housing is built, what is the embodied carbon as a result of new housing developments. So it was a multifaceted approach to targeting both energy consumption and renewable energy being generated. Next slide, please. So the energy option studies that were completed by Arup were just invaluable in terms of supporting. We had an overview of what our future growth and the impacts of that future growth would be in terms of net carbon, but this provided a really detailed understanding of on-site heat and electricity demand for those sites. These sites are all pre-planning, so it's really important that we had the understanding at the pre-planning stage. And the outcome is that they presented us with a range of renewable energy options and a short list of energy supply scenarios, which were very site specific. And the outcome of that was that the carbon emission assessments gave us the theoretical carbon emissions and carbon savings associated with each of those energy supply scenarios, so that it could inform the development, the planning of that site going forward. Next slide, please. And I just wanted to say it was important to stress that the Arup piece of work were very site specific. So alongside that piece of work, we've been working with our councils across the local authorities across the whole of Greater Lincolnshire on a Lincolnshire-wide energy options analysis, because Lincolnshire suffers with, like a lot of local authorities and rural local authorities, real energy supply constraints already. But also there are a whole range of opportunities because of the rural nature of the county for renewable energies and meeting our future energy demands. So it's really important that Lincoln is a very urban, very restrained urban area with limited land. We have to be looking at what's outside the boundary of our own local authority, what's happening outside, what's adding to those constraints, and what are the solutions. So it was a really important piece of work to sit alongside those site-specific energy studies. Next slide, please. And really, it was a combination of all of those, the local energy option studies, the Greater Lincolnshire energy options analysis, the policies within the Central Links local plan, and the council's net zero ambitions. It's a combination of that we're using to really engage with the private sector in terms of establishing private capital investment, which we have not had access to, or not really been in a position to access prior to all of this work being in place. So we're having really positive conversations around investment opportunities to do with district heat networks in the city, battery storage and the capacity for the city and land available to store energy, and discussions with landowners around opportunities to expand renewables within the city and outside outside our boundary. And it's alongside this private engagement. I just wanted to emphasise that the community engagement is also really strong and important to us. So it's equally important to continue with our ongoing community engagement. And in terms of investment, there's a real opportunity there to work with the community through community share schemes, so that the community have a really invested interest in what's happening and are part of that decision-making process for future-proofing Lincoln's energy solutions. And I'm now going to hand over to Jane for the question and answer session.
Well, thanks to all our presenters for really insightful and interesting presentations. Now we're going to get interactive and we will pose your questions and comments to our panel. So we'll introduce a question or a comment and then ask a particular panel member to give their views. So the first question we have is, what role does in-house energy storage play versus community level storage? So I think we'll start with Richard, if that's okay.
I mean, I think that's a tricky question. Clearly, in-house energy storage is probably more electricity than heat. I think you can't really store heat particularly well, other than for domestic hot water. It's actually less efficient to store it in properties than to store it centrally, in terms of capital costs and operating costs. But there are regulatory issues with communal storage for domestic property. So that's not a particularly clear answer. It's more efficient, but it's more efficient to do it centrally, but it's more difficult to do.
Thank you, Richard. Our second question is a question: is there any feasibility information on kinetic road capture? I'm not sure if it is road, but that's the question I have posed. So, Emir, can I direct this question to yourself?
Yeah, I'm afraid I don't know that one. I don't know what it's referring to. So I don't know whether that's kind of mobile charging perhaps for vehicles, but we're not involved in that area. We do work with the Department of Transport, but it's mostly around electrical vehicle charging points.
Yes, absolutely.
Richard has probably got something to add on that.
I mean, I don't know very much about Kinetic. I do know of a motorway in China which has got solar PV embedded all the way in the road surface, and clearly roads are open to the sky most of the time and have vehicles on them occasionally. That's perhaps a more viable way of generating energy on a development, to embed solar PV into the highways.
That's a Department of Transport role, really, rather than one for us. I mean, we tend to deal with, say, electric vehicle charging points at household level rather than at highways.
Yeah, there's a further comment on it in the chat. I think this was specifically around capturing the energy in roads when vehicles pass over ramps. So it's perhaps a technical one there.
My experience of those sort of things is that the quantum of energy that is produced is not generally worth the cost of building the equipment to make it to find the energy.
Okay, some very useful answers there, and I think that's something we'll take away with us to find a little bit more out about. So really good question. The next question is, what does demand levelling mean? And I think I'll direct this one to Steve.
Yeah, it's not a phrase that we've used in our presentation, I don't think, but I presume it's around.
It was Emir.
Yeah,
Oh.
I think maybe Emir might have some more insights, but I think it's broadly around demand shifting. Is that right, Emir? Which is reducing the peaks and troughs in the demand to align better with the generating profiles of the generating technologies, thereby increasing efficiency.
That's exactly right. Yeah, and using, if you've got batteries within the home, or actually even within cars parked on people's drives, you can kind of borrow and manage energy in a kind of site-wide way. And there's obviously lots of issues around personal data and GDPR and all those sort of things. So it's technically quite a complex area, but it's something that we're looking at, because you can potentially put less infrastructure in because you've already got infrastructure effectively sitting there on site. So it's just something that our energy consultants often refer to on bigger sites.
Great, thank you very much. The next question, this is a really interesting question. Does the panel feel that the future home standard goes far enough? Shouldn't we be building to passive house standard? Is there longer term plan to continue to build on these, on these standards? So I think I'll go to Emir first on this one.
Yeah, I've tried to answer this in the chat actually. So if you can see, I've typed something in, but we work with a massive range of partners, so I know I had to canter through quite a lot of information there. So apologies. I know one or two people have raised the issue that I was sort of going a bit quick, but there's a lot of information there. But one of the slides had a lot of our stakeholder partners that we're working with on the Future Homes Standard research, for example, and some of them that we work with, I can mention things like Good Homes Alliance. I think it's no secret that they want to go much further and faster than perhaps the government are going. I mean, effectively, Holmes England, we're an executive agency of DLUC, and policy is set at that level. So I'd have to refer any sort of policy questions like that really back to our department. So, if you've got issues with that or evidence, I mean, they're very interested, the department, in evidence, where we should be perhaps going further. So that's the question, that's if you've got evidence or examples of things like passive house models that can be built to the same costs and so on. They're very interested in the regulatory team, and DLUC are very interested in seeing that. But ultimately, so far, we're not in a prescriptive state. Holmes England, we follow what DLUC would do in this instance. So we're not going to go ahead of policy.
Lovely. Thanks, Emir, for that. And could I get a local authority view on this question, Kate? Does the Future Home Standard go far enough? Should we be building to passive house standards? And are there longer term plans around this area?
Yeah, so this was a lot of the discussions around when we were reviewing our Central Links local plan. How far do we go? Bearing in mind that the Future Home Standard was going to come in after our local plan was adopted. And the discussions were really around the fact that we wanted to absolutely guarantee that we set the standards within our local plan, as much as the powers that we could do anyway, because we didn't want to rely on the Future Home Standard to come in or perhaps be watered down, or at that stage we didn't know the results of the consultation weren't out. So for us, it was about embedding it within our local plan to give us the safety that we knew we could set those high standards. And in terms of passive house standards, we've set certainly in our social housing, we've set passive house as the standard that we aspire to, and we will be delivering in Lincoln and in our neighbouring local authorities. Whether that is too much of a transition on a huge scale for developers to adapt to, and whether that needs to be brought in over a gradual piece of time is not my area of expertise, but certainly it's something we're pushing for in Lincolnshire.
Thank you, Kate. That's really interesting, and pushing the boundaries with your local plan policies sounds really good. So perhaps could I just ask Richard and Steve?
I think Steve would be best on this.
Steve, okay. If Steve could give his views, that would be great.
Is this on the Future Home Standard?
Yes, absolutely. Does it go far enough? Should we be building to passive house standard, and any longer term plans?
So I think the answer to that question depends on who you ask, because there's obviously a tension between a societal need to achieve net zero, and from that perspective, anything that isn't aligning with net zero isn't going far enough. But for a developer who might be facing supply chain issues and rising costs and pressure to deliver more houses, they might think that it goes too far. So I think what is seemingly happening is government trying to balance the tension there, and also looking to not mandate a step change that will also reduce the amount of homes that will be built and present too much of a challenge, because obviously they're trying to deliver a certain number of homes across the country to address rising house prices and things like that. So I think it's a subjective question, really. Personally, my perspective is that we should be trying to aim for as low carbon as possible.
Thanks, Steve. And I think that incremental change point of yours is, really important, isn't it? Especially in terms of all our supply chains for the industry and whatever as well. So thank you. Some really great thoughts on that. Really good question. So just moving on to our next question, SMEs. Are SMEs considered in your consultation process, and I think that was one that Richard and Steve mentioned. So I don't know, Richard, if that rings a bell with you, that you mentioned that in your presentation.
Yeah, we did specifically think about it where we looked at rural urban extension, because we recognise that in those circumstances there are far more SMEs going to be delivering those schemes, and we did think specifically about technologies that wouldn't prevent SMEs being part of the solution. So that's where we specifically looked at it, and we recognise that there are some solutions to this that actually are quite challenging for SMEs because of the complexity of them and the time it takes to grow experience, for smaller businesses to grow experience in new systems. So to some extent we took account of it in the work we did, yes.
Thank you. That's a great response. Thanks, Richard. Just going on to the next question about carbon emissions. Carbon emissions from homes is one thing, but carbon emissions from transport is another. What are we doing about requiring high density mixed use developments? I think I'm going to actually go to Kate first to see from the local authority perspective. What do you think?
I don't quite know how to answer that, Jane. Can you just ask it again?
Yes, of course, yes. So carbon emissions from homes is one thing, but carbon emissions from transport is another. So I think this is all about, how far are people travelling, from where they live and all that sort of stuff.
It. Yeah. So this was another area of our Central Links local plan. There was a very much a political steer that development didn't continue to take place in remote rural locations, and that it was focused around sort of urban hubs that we have across the county, and that's primarily for a city like Lincoln, where we've probably got a shortage of family homes. People are looking to sort of a half an hour commute outside the city for the space and family homes, to then having to commute into the city. So it's really important for us that we look at those sites in terms of access to the city centre, public transport access, cycle routes, sort of a really holistic approach to development sites, because we've got to really attract people to stop commuting, which is a real. It's been a real tradition in Lincolnshire. You get in your car and you commute somewhere because there isn't an alternative option, and that we really sort of turn that round and encourage people to want to live and invest and work in the city, to reduce those transport miles.
Brilliant. Very insightful. Thank you very much for that. And I think a lot of our local authorities are thinking the same as yourself, Kate. And I'm just going to give Emir just a couple of minutes just to give his views on this one, because I know it's a subject, carbon emissions from homes being one thing, but carbon emissions from transport being another. What are we doing about requiring high density mixed use development? So Emir, if you'd just like to give your views on that.
Sure. I know, I covered, I think, in my talk a little bit about how the Future Home Standard sits within a suite of different pieces of legislation, guidance and best practice and so on. And a good low carbon strategy, wouldn't just cover the building fabric and the renewable energy tech, but also how people use the site or how they get to work and all those sort of things as well. So a good analysis would capture all that. There's a lot of questions in the chat about things like technology, and particularly passive house as a method. I mean, I tried to answer that in a written piece in the chat, but we're not technology agnostic in that regard. We can't be, because we can't prescribe a particular method or a technology. A passive house is obviously a very good fabric first tech, which achieves zero carbon, but it's certified. and is a very good one. But it's just we would push it onto the developer partner to choose which method to achieve based on the standard that was being set for that site. But in terms of things like ambition, I think like Stephen said before, the best thing to do surely is to try and aim as high as you can, and you'll get part mostly there. I think if all the partners are quite committed to those goals. But you have to go through options appraisal and costing and all the rest of it, and you discount models. Some of them are not environmentally the most optimal model for a particular site. So even though it might sound good or look good, it actually doesn't suit a site. Maybe nothing to do with the finance. It might not be the best method. So I think that you need to go through those kind of options appraisal to see what's best. But of course, Holmes England do have, just in conclusion, kind of a placemaking role. So there's no point in us having a zero carbon home if somebody's then having to drive, even if it's an electric car, 50 miles to work every day. If we can produce a model that's much more lower carbon in terms of food miles and commuting and so on, then that's surely the best aim for better lifestyles all round, not just zero carbon buildings.
Absolutely. Thank you, Emir. Our next question is around viability and affordable housing, and balancing this with carbon neutral changes. So I think, first of all, I'll go to Kate, and then I'll go to Richard. So the full question, Kate, is viability is a major issue with impact on affordable housing numbers. How do we balance this? How do we balance this out with increased costs from carbon neutral changes?
So addressing the issue of affordable housing was already a significant issue for us here in Lincolnshire because of the land values that we're faced with and viability issues. It was already regularly challenged in terms of viability for affordable housing. I don't think we have an awful lot of choice, do we? We still need, and I think this is where the local authority comes in, and working with our partners, our registered social housing partners. We're looking at sites in the city, and most of the city council owned sites, which we have a fair few, are all about meeting that affordable housing need. So we're working with the developers to provide the land and make land available to expand our affordable housing and meet that need. But I really don't know how that's going to affect in terms of viability because of the increased costs. Ideally, those costs are going to come down as the more houses we develop. The prices will come down in terms of the technology and the pressure on the developers. But it's an unknown at the moment, isn't it?
Thank you, Kate. Yes, it is a bit of horizon gazing at the moment on that issue, but a really important one and a good question. So, Richard, just any comments from yourself?
No, it is a major challenge. It is a major challenge. There are capital costs increases, there are operating costs for consumers increases. It is part of, I think, or one side of where the costs increase for getting towards net zero, and I think dealing with it is part of a rebalancing of the UK economy to take from where the benefits of being net zero and spreading those benefits to where there's the financial challenge of being net zero.
Okay, yeah, thank you very much. So moving on to grid connection now, another really good question. How do we tackle the issue around lack of grid connection, viability and restrictions on direct wire to deliver zero carbon energy to development? So, Emir, just your views to start off with.
Sure. Well, I mean, we've got a range of sites. Obviously, we have to work with the DNO, the networks provider, to get electricity into a site, and they vary massively in what that capacity is. And obviously, that has to be paid for, and it's it can be millions and millions of pounds up front. And obviously, if you've got very much an electric only strategy, it can be even higher because you might have to put in additional substations and so on. So that's when we do what I was talking about before, really, which is some of this optioneering and options appraisal. Is there a degree of generation you can do on site to perhaps have avoided costs and perhaps build one less substation, or is that the fixed cost that you've got? And we would work with obviously consultants like Arup, WSP, and all the rest of them to kind of do some of that analysis, and then judgments and decisions are taken on that basis. But obviously, it can bring some sites, into territory of unviability. So there's some difficult decisions to be made, often driven by what comes out of the electrification strategy.
Brilliant, thank you. And just to hand over very quickly to Steve for his views on this one.
Yeah, thanks, Jane. I think it's a very pertinent issue at the moment, and we've seen reports of some generators looking at connection times of in excess of 10 years, and we've heard lots of stories around developments having real challenges achieving those grid connections. But I think that broadly that's as a result of increasing capacity and an aging electricity network and all these sorts of things. So some of the measures that we can take, I think that one of the most important ones is actually energy efficiency. Actually reducing the amount of energy that's required in the first place should be a priority, and is really, if you look at the hierarchy of energy, should really be the sort of the core one at the bottom that people think about. We touched upon integrating storage, and try and move in towards a smarter energy system on development can also help to try and manage energy better, to try and reduce peaks and troughs. So those are two key sort of approaches that people can take, but broadly it is a real challenge for the UK, and one that many people are going to have to focus on looking at. You have a point there, Richard?
Yeah, I was going to say, as you showed in our slides, Steve, that our view is that the increasing grid size is between 1.3 and 1.5 times what you would typically have had. I suspect some developers are getting numbers that are much bigger than that, and I think that's about the quality of the analysis. So I don't think it's quite as big as perhaps some people think. And the question was also about how to essentially make best use of private wire. And for domestic premises, there is a regulatory change needed. That it is limited by regulation. It goes back to the Electricity Act, revised in 1999. So there is some regulation needed to be changed to take the benefit of being able to use private wires for domestic consumers, and it would make a significant commercial benefit to both the investor in the renewables and the consumers.
Thank you very much. Right, well, I'm afraid we've come to the end of our questions and answers, but we will take away and have a look at all the further questions and bear them in mind, when we're developing our view on particular technology or policy aspects of this subject. So before I just go through the closing session, the wrap up, I'd now like to hand over to Emir, who's going to talk to us about those top tips and sources of further information. So Emir, if I can invite you to speak again.
Thanks very much, Jane. So yes, as some people have mentioned in the chat, we've obviously covered an awful lot of material today. So apologies if we've bombarded you with a lot of stuff, but you will be getting this slide deck as a takeout, and obviously you're welcome to come to us for any follow-up on anything we've not been able to answer today. But in terms of the sort of concluding points, what we were hoping really was to just set out really what our stance is on kind of on government policy on reducing energy and carbon emissions. The future direction in terms of what we're doing in terms of looking at future energy solutions, and how our future homes standard pilot, how we're going to engage with partners, and so the local partners, all of you on the call, really, how we work with you on the local energy plans and policies and planning, some of the private sector engagement with the developers, consultants, and so on. And then kind of, the kind of the consulting side, which Richard and Stephen have covered, kind of what methods do we use, is what's best for each site, and how do we make those decisions? Because there's been a tremendous amount of information in the chat today, isn't there, about kind of differing approaches, and we need to narrow down, particularly for each individual site, what is the most optimal most optimal method really to achieve low and zero carbon. So thank you very much.
Brilliant. Thank you, Emir. I'm just going to see if I've got any other messaging that we need to give you. Is there any other messaging from any of my colleagues that we'd like to give you before we say a big thank you to you?
We're all good, Jane. Thanks very much. And yeah, thanks to yourself for fabulous chairing, and thanks everybody for coming.
Yeah. Thanks to everyone, and goodbye, and have a good day. Thank you very much.